Welcome to Built, Wired, and Secured, the podcast where we explore how modern buildings are designed, connected, and protected in the real world. I'm Alex Morgan, and in today's episode, we're diving into the spare parts problem, lifecycle planning for building tech, why it matters, where projects usually go wrong, and what decision makers need to understand before problems show up in production.
Joining me today is Michael Harrington. Michael brings decades running operations for commercial portfolios, and today we'll unpack how spare parts, firmware life cycles, and vendor continuity decisions either reduce downtime or create cascading failures.
Thanks, Alex. I'll start by saying this. Decisions that save a few $1,000s at purchase time are fine, until they fail. Then everyone asks, what breaks if this goes down? And the answer becomes painfully expensive.
Let's set the scope. Buildings are full of diverse assets: switches, controllers, access readers, sensors, controllers, and appliances, each with its own firmware, support contract, and replacement part. The real issue is not just that parts fail, but that the replacement ecosystem evolves. SKUs are retired, firmware moves on, and sourcing becomes a scavenger hunt. Michael, how do you describe that hidden dependency in plain terms for a facilities leader?
In plain terms, a building is only as available as the least replaceable component. You can think of it like a supply chain that lives inside your walls. If a critical component becomes unavailable, you either retrofit around it, find an expensive one-off replacement, or accept reduced functionality. From an operational standpoint, that's a risk that shows up in the capital plan if you manage it, or as an emergency expense if you don't.
Segment 1. Inventory and BOMs. Michael, walk us through practical steps teams can take to build an owner-focused bill of materials that avoids the mystery box problem.
Start with an owner-centric BOM, not a vendor BOM. That means you catalog functional roles first, what this device does for building operations, and then map SKUs, firmware versions, serial ranges, and supplier options beneath that function. Don't stop at model numbers. Record procurement date, warranty end, firmware baseline, and compatible interchangeables. A one-line item that says access controller isn't actionable. A structured BOM that ties function to replacement options makes procurement decisions faster and less risky.
What common pitfalls do you see when teams try to create that BOM? Where do people waste time or make mistakes?
3 pitfalls. First, relying solely on vendor documentation, which disappears when products go EOL. Second, asset data living in silos, operations spreadsheets, ITCMDBs, and contractor notes that never sync. Third, ignoring firmware and compatibility notes. If you only track hardware, you miss the software layer that determines whether a replacement will actually work. Fix those, and you already cut your emergency time in half.
Segment 2. Obsolescence and vendor continuity. There's a decision spectrum here: extended warranties, stocking spares, third-party sourcing, or running to failure. How do you frame trade-offs for a property owner deciding where to invest?
It starts with risk tiering. Not every device merits a factory spare or extended support. Classify assets by impact: safety critical, tenant-facing revenue impact, operationally essential, and convenience. For safety critical, elevators, fire systems, controlled access, you budget for immediate replacement options and stricter vendor continuity requirements. For convenience items, run to failure could be acceptable. Then layer in lead times and supply risk. A low-cost item with a 6-month lead time is effectively high risk if you rely on it daily.
How do you feel about third-party suppliers or refurbished parts as a continuity strategy? There's often resistance from procurement or legal teams.
Third-party sourcing is pragmatic, but it requires governance. Third-party or refurbished parts can keep systems online, but you need acceptance criteria: functional testing, firmware parity, and an agreed failure mode. If the vendor refuses non-OEM parts, document that risk and price it into your capital plan. The key is making an informed choice, not a blind rejection or an unvetted save.
Segment 3. operational playbooks, and capital planning. We talk about bombs and risk tiers, but how do you turn that into a living playbook and an actual capital refresh schedule?
Translate asset criticality into 3 outputs: a spare parts list, a refresh cadence, and a simple runbook. The spare list captures what to hold on site, in a regional warehouse or via a contracted supplier. The refresh cadence ties expected lifespan, firmware support end dates, and vendor roadmaps into multi-year capital forecasts. The runbook is the operations-level playbook: who to call, what temporary mitigations work, and what approvals are needed for emergency procurements. Keep the runbook 1 page per failure scenario.
You mentioned runbooks being 1 page. Can you give an example of what that looks like for a common failure, like a door controller going offline?
Sure. Header: door controller offline. Impact: affects X doors, tenants Y. Immediate action: switch to manual lock override procedure and notify security. Short-term mitigation: deploy on-site spare controller Z, part number, load configuration from backed-up profile, validate firmware match. Escalation: if spare not available, call pre-approved third-party supplier and initiate emergency procurement. Owner sign-off thresholds and communication templates are included. That's it. Clear, fast, repeatable.
Expert examples. Can you share 2 quick anonymized stories where proactive planning saved time and money?
Example 1. A downtown office where the team tracked firmware end of support for access controllers. They pre-purchased a limited stock of compatible controllers and staged them off-site. When a vendor discontinued the model unexpectedly, they completed a controlled swap over a weekend with no tenant impact, an expense of a few $1,000s versus days of lost access and reputational cost. A campus that categorized its HVAC controllers by criticality and scheduled a 5-year phased refresh funded through operating reserves. When a supply chain disruption doubled lead times, they had already replaced half the fleet and used planned budgets rather than emergency capital, avoiding expedited freight and overtime costs.
Key takeaways. For listeners today, what concrete actions should property and operations teams take in the next 30 to 90 days?
3 action prompts. 1. Build or update an owner-centric BOM that includes firmware and support dates. 2. Tier assets by operational impact and define a spare strategy per tier. 3. Create 1-page runbooks for your top 5 failure scenarios and link them to capital refresh schedules. If you do those 3 things, you'll be far less likely to be surprised.
We've prepared a downloadable checklist and a sample spare parts runbook template to help you get started. Visit the show site for those resources and use them in your next capital or operations review. That wraps up today's episode of Built, Wired, and Secured. We covered lifecycle planning and spare parts strategies so you can reduce downtime and make better capital decisions, and hopefully gave you a clearer way to think about how these decisions play out beyond the initial install. Thanks for spending time with us. Until next time, make sure the systems you're responsible for are built to last, wired with intention, and secured for the real world.